what I'm going to give you is a very wide, broad overview on carbon. And I hope by now you have all seen the Elements exhibition, have you? Yeah, great. And so you probably recognize this interactive periodic table, which is my favorite one. And then let's see where carbon is. Here it is. He got a lot of attraction, as you can see. A lot of people stop by the carbon. And actually, carbon is an amazing element. If you think that is the 15th most abundant element in the Earth crust, or the 4th most abundant element in the universe by mass, or the second one most abundant in the human body by mass, that gives you an idea of how important carbon is. And, well, carbon is derived from the Latin word carbo, which means charcoal. You may all be familiar with this. But you also may recognize a few other forms, graphite, and maybe if you don't recognize this one, I'm pretty sure all of you can relate to this one, because you all use it, right? And this is all carbon. But do you know another form of carbon by any chance? Anyone has another idea? Yeah? Is it something like this? Lead, it's a different element. But what about this nice transparent one? And maybe if I show you this one, you recognize it. Diamond, yeah. So diamond is also a form of carbon. And, well, actually, both graphite and diamond have been known since ancient times. It's just that people didn't realize in the ancient time that both graphite and diamond were made of the same element, carbon. Actually, in the, let's say, 18th century, some scientists discovered that indeed they were charcoal, diamond, graphite were all form of the same element, carbon. And you know how they did that? They actually burned diamond. They took diamond and they burned it with oxygen at very high temperature. And they really destroyed this beautiful, precious gem. And they realized that when you do that, you don't form water, and you only form carbon dioxide. And they recognize the same amount of carbon dioxide being formed by the same amount of charcoal and diamond, and later on graphite. So they say, actually, they're all from the same element, carbon. So how come, actually, in the Science Gallery exhibition, if you may have seen a diamond, and in this case, you know, they say diamonds are forever. Actually, they actually do nowadays diamond from the ashes of beloved ones that passed away so that you can wear them forever. But in reality, if we look at the allotrope diamond, it's not the most stable one. So they're not really forever. The most stable one is the graphite. So if you wait long enough, you may see that diamond can actually turn into graphite. Fortunately, the activation energy to do that is very high, so it will take a very long time. So don't worry, your diamond will stay the same. But it's not the most stable one. So what is the difference? How come that the same element can give you materials with very different properties? You can go, as I said, diamond and graphite are two examples, and you can see with your naked eyes. I mean, diamond is transparent, graphite is black, very different properties. How is that possible? And it's simply by the arrangement of the different carbon atom in the space. So if we look in this one here, you can see that the diamond, every little ball is a carbon atom. So in the diamond, every carbon bonds to other 4 carbon atoms in a 3D space. While in graphite, every carbon bonds with 3 different carbon atoms in a planar space, right? And then there are other allotropes, such as this polymer here, or recently, in the last 25 years, new forms of carbon have been discovered. Now, 2 of them, the first one here, the buckyball, which basically is 16 carbon atoms that are shaped in the shape of a soccer ball. Or you also have carbon nanotubes, and we'll see a great talk later on, which is really a hollow cylinder of carbon, or graphene. And you can see that 2 out of these 3 different allotropes of carbon receive Nobel Prizes to tell you how important they are. So you will see more about this later. I'm just giving you a little bit of a representation of how you can see the differences. They're all carbon atoms, and just the way you roll up this sheet of carbon, you can form different materials. Okay, carbon also can bond to many other elements of the periodic table and actually can form more than 10 million different compounds. It can have bonds with hydrogen, and in that case you have hydrocarbons that you need for energy. With oxygen you have sugars, you also need sugars for energy. With nitrogen you can have alkaloids such as nicotine, caffeine, also energy is involved in there. And with sulfur, you get antibiotics, and with phosphorus, you get DNA. So carbon is the element of life. So today is the last day of the elements. I really hope you enjoyed the exhibition. If you haven't seen it yet, I strongly recommend it. And then I'd like to let you know that Elements will move to Bergamo in Italy, which is my hometown, for the Bergamo Science Festival. And the exhibition will open on the 16th of October, and it will be open for a month. So if you haven't been to Bergamo, it's a really beautiful place in the north of Italy near Milano, and you can fly directly from Dublin. So I strongly recommend your visit. Thank you.